Hello, can you hear me?
Yes.
How are you all doing?
Good.
Right. Tonight, I couldn't make it to the campus, and for unforeseen circumstance, so I decided to have this just like we did last week. So let's start. First of all, let me show you what you have this week. I have you this week. Announcements.
Professor, I have a question.
Go ahead, I'm listening.
Did you ever post classwork number 8?
Hold on, let me see. You mean the one for last week?
Yeah, because I tried to do it, but it wasn't available.
No, I didn't give a class. Hold on, let me make sure. I didn't give a class work last week.
Okay.
I didn't give a class work last week. So I'm gonna use the one I'll give you today. That will take care of last week and this week. Okay. So you get you get two things for doing one. Okay. Hello, can you hear me?
Yeah, I can hear you.
Okay, good.
Well, since there's 2, are you able to give us extra time to complete them?
How? You say?
Since you're giving us 2 classworks, will you give us like extra time to complete them?
Yeah, I will accept it. If you look at the, let me show you. We look at this the due date. I'm gonna change it to next week so that you'll have time to do both of them. Upload one here and upload the other one here. Okay. So I'm gonna change these due dates now. Let me change it to next week. Yeah, so that was a good question. So I have not posted it yet, but I'll post it before we leave. So I'm going to change the due dates right away to next week. Yeah, I got it next week. I will make it. This is today is 7th. Okay, I'll make it on 14th. Both of them. I think that should take care of it.
Thank you. And you said that for the both of them?
Yeah. What I'm going to give you will take care of both of them.
Okay. Thank you.
So let me change the other one to next as well.
Professor, I sent you an email.
Who's on the line now?
Jeru. Kamani.
Kima, I didn't reply.
No.
Okay, I'm gonna read it after. When you send it?
A day or 2 ago.
Okay, I'll go there. I'll check. I'll reply. I'll send you a reply tonight. Nothing to worry.
Yeah, 2 days ago. Okay, thank you.
You're welcome. So I'm gonna make it due on 14th as well. Other than that, other assignments are due this week. So this week will be a busy week for you. Be a busy week because we are getting toward the end of the semester. So we have 4 assignments. One of them is classwork 9, which I will give you the question, and I will use it for both of classwork 8 and 9. Then the other one is homework 8. Homework 8 will be on confidence interval. As a matter of fact, I'm gonna change it to the due date to next week as well, because since we're not in the campus, we may not be able to finish everything. So let me do it right now before I forget. But test 2 is you have to, that one is covered the stuff we have before. Probability, binomial, and also normal. So that one is due this Monday. So I'll leave it on Monday. So, but for homework 8, let me move it to next week. Yeah, so that by that time we'll cover everything on it. So we did this. You know what? I will, yeah, I'll edit it. And, yeah, let me edit it in this homework 8. Yeah, let me edit it in, because from now on, I think you can access your homework from directly from Canvas. I'll make it, when I make this correction now, it will reflect in my MATLAB. So I'm going to make it to be due. It's supposed to be due on the 11th. So I'm going to change it to 17th. Yeah. But test 2, you have to do it this week because we have done those ones already. Yeah, excellent. Now, so I have taken care of this important thing so that I won't forget it. And also, that should give you more time to work on this. So even though I wrote that homework is due on the April 11th, I've changed it to next week. Then, but test 2 stays the same. Excel assignment stay the same. And then classwork, I've also moved it to next week. So that's taken care of. Now, let us begin. I hope you have started working on your project. The earlier you begin, the better for you. What we have tonight is what's called confidence interval, where we make an estimate of a population parameter. So confidence interval, simply we do for the confidence interval for the mean and for proportion. So confidence interval for the mean gives an estimated range of values that will include an unknown population parameter. So we're trying to estimate the range of values, the lower range and upper range of a population parameter. And when we say population parameter, we are referring to things like the mean, and see them here, standard deviation, proportion, and so on. For example, in a confidence interval for the mean, if you say we are trying to get a confidence interval for the mean, that means we are trying to estimate the true population mean. So instead of using a single value, we get a range. We can see that examples, you can see this is the mean we are trying to estimate, or the standard deviation. So we get the lower mean, lower range for the mean, upper range for the mean, or lower range for the standard deviation, and upper range for the standard deviation. Now, but I'm sure what we are most conversant with is the point estimate, which they can say that average price of gas is $2.34, for example. So that's one number. So in the point estimate is a single numerical value estimate of the population parameter. And the best point estimate of a population parameter I would say the best point estimate of the population mean is the sample mean. Example of point estimates are as follows. I'll give you 2 examples that can make you to understand it better. See, the local bus driver might claim that the average price of gas is $2.34. No, it's bigger now. I think it's almost $4 now because of this the war in Ukraine. Now, you can see the average price for all the gas in, whatever it is $2.34. That was the claim. Is one number. How about this? His CEO can say that, or Ford CEO can say that the company produced on average 200,000 cars in the year 2013. 200,000, one number. Now, let us differentiate this from the interval estimate, which is the one we are interested in tonight. It goes this way. That says give us a range of values that will contain the population parameter. The same bus driver might say, or might claim that the average price of gas in 2018 was between $2 to $3. See, That is two numbers, a range, the lower range and the upper range. So that is what we are interested in. It is more better to use that than to use a single number. The point is made. How about this? The same CEO of Ford Motors might say that the company produced on average between 190,000 cars to 250,000 cars in 2013. See, two numbers. Here, it is only one number, 200,000 cars. But here, you can see the two numbers, the lower range and the upper range. See, that's what we are trying to do here when we are doing a confidence interval, to estimate the value that will be for the lower range and that value can be for the upper range. So when we do that, we make use of some confidence levels. A confidence level simply means I'll call it the likelihood that the true population parameter lies within that two range that we are trying to estimate. So we are our degree of confidence, or the likelihood that the true population parameter lies within the range that is specified in the confidence interval. You can use different confidence levels, but in statistics, the most popular ones are the 90% confidence level, 95% confidence level, and 99% confidence level. These are the popular ones. You can use any confidence level. For example, if you say that you are 95% confident, that means that your chance of being wrong is 10%. See? Which means that your alpha, they call it alpha, which is the probability of being wrong, committing a type 1 error. You mean that your alpha will be 0.10, which means 10%. So if you say that you're 90% confident that the amount of cars, the quantity of cars produced by Ford is 190,000 cars to 250,000 cars. That means your chance of being wrong is 10%. Now, if you say that you're 95% confident, it means that your chance of being wrong is only 5%, which means that your alpha will be 0.05, and so on and so forth. As a matter of fact, I have them all written here in this table. Let me bring it up a little bit. Yeah. See? So if your confidence level is 99%, for example, if you're making if you're manufacturing medications, those in the pharmaceutical industry, they have to be at least 99% sure. That means your chance of being wrong is 1%. That makes your alpha to be 0.01. So then critical values are the values that you subtract at the lower end to get the lower value, lower confidence interval. And that, sorry, we use the critical value. My mistake, don't worry. I take that back. Critical value is basically the value you use to calculate the error margin. So now we get this one from the table, the table of normal distribution for this type of confidence interval. So I will show you how to get this in a moment. So now, those that do the DNA test, if you hear them, they'll say, oh, we are 99.9% sure that the baby is yours. That is 99% confidence interval. So their chance of being wrong will be only 1%, making their alpha to be 0.01. Now I'm going to show you how to get these critical values. To get the critical values, we use this formula. I'm going to show you now. The formula is, there are two ways actually. There's a method that are described in your textbook. You can use that if you know how to use it. Otherwise, you can use a shortcut formula that I normally use to get confidence critical value. That formula is this: Z alpha over 2 equals P over 200. Now, let me explain this. Z alpha over 2, because there are two sides, lower side, upper side. So lower interval, upper interval. So that's why you have alpha over 2. It's P represent the confidence level, as in this confidence level. And 200. Now, you know that percent is 100. But because you have two sides, we use 200. Let me show you how it works. So let's say that you want to get the critical value for 90%. So what we're going to do here is to say critical value, Z alpha over 2 is already here. So I'm going to put equal sign here. Equal, okay? You say P over 200. For 90%, P is 90. So you're going to be 90 over 200. I'll make this in big. So let's see it. 90 over 200. That will give us some. Okay, I'm going to make it a little bit more big. That's 90 over 200. That makes it equals. We're going to put this on the calculator. We have our free calculator, free scientific calculator. But you see, it's 90 over 200. 90 over 200. Share this. So I'm going to have 90 divided by 200. I got 0.45. 0.45. So I'm going to write it down. 0.45. 0.45. But you know, in the statistical table of normal distribution, they all have 4 digits. So I'm going to make it, use 2 zeros to make it 4 digits. Now we're going to look at the table. Inside the table, we did this last week. So go inside the table. This is the table of normal distribution. Remember, I said print this table. I'm going to scroll down to that we have it. That's right here, table 5. So inside table 5, we'll be looking for the value 0.4500. If you don't see that value, look for the value that is closest to it. Yeah. So I go here. I look for 0.4500 inside. I see two things: 0.4495 and 0.4505. Now these numbers, both of them are equally close, and I will show you what I mean by that. I'll ignore the decimal point and write them as 4495 and 4505. But what we're looking for is 44. We're looking for 4500. So we subtract them from 4500. See how many points they are away. So I'm going to show you in the calculator. I got the first one. I have ignoring the decimal point, 4500 minus 4495. We have 5 points, see? 5 points. Now, if I repeat the same process with the other number, which is that 4505 minus our number, which is 4500. You see, it is also 5 points. So both of them are equally close. So when we have this kind of issue, what we do is to P the bigger number of the two. So we P this one, it's bigger, and we follow it to the left. Give me 1.6 up 5. That's it right there. So follow it to the left, you see 1.6, and if you follow it up, you see 5. So that gives us 1.65 as a critical value. 1.65. And you can see it right here. You can see it right there. Now, for this one, is what they did is that they use the two numbers and find the average. The average gave them this, which is still the same thing. If you round it, if you want to round it, to give you 1.65. Any question on this? Any question? Very good, no question. Excellent, excellent. Now let's try, just in case you see this in your homework. It says, find the critical value, Z alpha over 2, corresponding to 95% confidence level. So solution. So first of all, copy the formula and put it right here. Okay. Put the formula here. Now, you say for 95% confidence. So just put equal sign. Use P, critical value Z alpha over 2 is P over 200. Now P in this case is 95%, so 95 over 200. Now I'm going to make it this thing to be bigger. 95 over 200. So make it a little bit bigger. So that gives us some. I'm going to calculate 5 divided by 200. 95 by 200. 0.475. I mean, it's 0.475. That 0.475. 0.4750. Now, I put 0 there because remember the table, all the numbers are 4 digits. So if it's not up to 4 digits, you use 0 to make it 4 digits. So now, next thing we do is to go to the our table of normal distribution. 0.45. I think it's what we have was 0.4750. Let me write it down. 0.4750. 0.4750. Okay, so we get the critical value by looking for this inside the table. So we go inside the table and then look for that 0.4750. If you don't see it, we choose the number that is closest to it. So we are lucky this time. We saw it right here, 0.4750. You follow it to the left, 1.9, then up 6. See, follow it to the left, 1.9. Okay, then 6. So answer is critical value is 1.96. 1.96. And you can see it's right here. See? So for most questions, they will give you the critical value, this confidence level. So you already know the critical values. Otherwise, if they don't give it, you calculate it. Why? Before you calculate the confidence interval, the lower interval, upper interval, you must get the error margin. And to get the error margin, you need to get the critical value first. So now, so I've given you 2 examples. Now let's apply it here. You can try part 2 and part 3 as a practice. So let's do it. Starting with confidence interval for the mean. So let's do it for the first case. 1 is for large sample. In statistics, we say that the sample is large if it is greater than or equal to 30, provided that they are selected at random. So the first one we do is for large sample in which the population standard deviation is known. The steps are as follows. First thing you have to do is to find the critical value, which I just showed you how to find it. Then calculate the error margin using this formula here. Then subtract the error on the left side. Because what you are trying to estimate is this mean. So you subtract the error on the left side, then add the error on the right side. That's it. And you get your confidence interval. So let's do it. Now remember that the best point estimate of the population parameter, so population mean, is the sample mean. Let's just try this example here. It says, a sample of reading scores of 35 fifth graders has a mean of 82. That is sample of 35. The standard deviation of the population is 15. It says find the best point estimate of the mean. Remember, I said here that the best point estimate of the population mean is the sample mean. And here they told you that the sample of 35, that the sample mean is 82. So that answered the question right there. So the answer becomes a solution. So the best point estimate of the sample mean of the population mean is the sample mean. So you just write sample mean. I'm gonna get it. This workbook will allow us to get some formulas for the sample mean. So I'm gonna go and get it from the other workbook. So have sample mean equals 82. So I'm gonna get it from here. I can write, or you know what? Well, let's see, get it. Let's see, get it from here. So we have sample mean. So sample mean which is X bar. X bar. That come from here. S bar. Okay. Equals 82. 82. So I'm going to make it big and then take it to that side, to that workbook. So that answered the question right there. So I'm going to take this to our main workbook and put the answer right there. Yeah, for A. Any question on A? Any question on this? Hello, scholars. Any question?
I mean, from this part, no, since the mean has already been given.
Yeah, it's already given, exactly. They gave it already. So yeah. So now, okay, let's try the next one. Next one is where you get actually do the work. More work. It says 7 fifth graders. Say there are a sample of 35 sixth graders. So has a mean of 82. That's for the sample, and the standard deviation of 15. Now this one they give you is a point estimate. So yeah, but this time you're looking for the entire estimate. It says here that the standard deviation is 15. They find the 95% confidence interval for the mean reading scores of all 50 graders. Now remember I explained this step. First thing is to find a critical value. Then find the error margin. And then find the confidence level. So let us first of all list our numbers in. He said it's a sample of 35. So N is 35. 35 fifth graders. Yeah. 35. That's 55 fifth graders. The sample mean is 82. So what is the sample mean here? Is 82. You have it already. Sample right here. It looks like, look, I'm going to move down a little bit so that we can have enough room for this. Yeah, you see this is filled. Now, so let me move it down a little bit. Okay. Yeah. Now, next thing is it says that the standard deviation is 15. Okay. The standard deviation for the population, I'm going to put it here. The standard deviation is 15. It always change to this number. I don't know why. It always does that. Okay, delta symbol. Okay. Now, next, once you have this, we need to get our critical value now. Say, find a critical value. Now, we already have it. Remember, I showed you how to get it here. 95% is 1.96, right? So I'll write it down right there. Z alpha over 2 is 1.96 because say find the 95% confidence. So I'm going to write it. This will not allow us to get it. Yeah, so I'm going to go to the other workbook. So that the critical value is Z alpha over 2. Have Z Z alpha over 2. We're going to get it from here. Move fast. Okay, Z alpha over 2, the alpha somewhere here. Alpha over 2 is 1.96. So I'm gonna copy this. I'll make it a little bit bigger, you know, copy so it would be 16. Okay, copy it, go to our workbook and paste it in our main workbook and paste it. So we have a critical value right there, 1.96. So we have a sample size, sample mean, standard deviation, confidence, critical value. Next is to find the error margin. We collect this to find the error margin. Okay. Error margin. Put it here. See, that's the formula for the error margin. This critical value times standard deviation over root n. I'm going to write this down so we can go and put it in. Critical value is 1.96 times standard deviation of 15 over the square root of n, which is n is 35 sample size. So we go to our book. So we can paste it there and get our answer, the formula in. So it's gonna be I'm gonna paste it here. So we can put it in equals. We have 1.96, 1.96. Okay, times the standard deviation over root n. The standard deviation is 15 over the square root of n. Square root of n, our n is 35, and that gives us. I'm gonna put this on the calculator. So I have the calculator. Know what it is. I'm going to remove some of this because they won't let us see the other. Yeah. Wow, the board just went blank. Anyway, let me put the calculator here so I can share it. So calculator and then share it. Okay, let's do it. So you can see the calculator, right? Can you? Hello, scholars.
Yes.
Okay, good. So we have 1.96, 1.96 times, okay, times, have standard deviation of 15, okay, divided by square root of n of n is 35, so 35, okay, close it. You have 4.9695 and so on. So you use 4.97. 4.97, let me write down 4.97. So let me write down 4.97. So now we go back to our workbook. Our book, which is right here. And share it. So I will share the new workbook. Yep, I got it. So I got 4.97. Okay. So I'm gonna copy this and put in our main workbook. So to give us our answer. So you share my screen just changed. Anyway, I think you get it. So I got it right here. So I'm gonna paste it here. So you can see our error. Right here. Our error. So now we have gotten our error margin. Next thing is to find the confidence interval. So what we're looking for is the 95% confidence interval. So it is given by this formula here. You subtract the error on the left side and you add the error on the right side. So you go 95% confidence interval, 95% percent confidence interval is this S bar minus error. That's the mean, the S bar plus error. So our S bar is, sample mean is 82 minus error of 4.97. Yeah, less than the mean. Okay, less than the mean, which we are trying to estimate, then less than the S bar, which is 82, plus error of 4.97. So with a calculator, you can get this as 82 minus 4.97. We got our calculator as 82 minus 4.97. Yeah, it's gonna be somewhere here. Yeah. So I'm gonna move this up so we can get our error. You can see the calculator now. Okay, good, I believe. Okay, sure. Cool. So you have 82 minus 4.97. We got 82 minus 4.97. It was 77.03 on the left side. On the right side, you add it plus 86.97. So we have it. I'm taking you back to the to our book. So we have it here as. So on the right side, I will copy the same thing so we can save time. Then we put the answers right there. Okay. So we have on this side, if you subtract this, you get, like I showed you on the calculator, it is 77.03, less than the mean. On this side, 82 plus 4.97 give us 86.97. So this is their confidence interval. So conclusion is this. So we can say with, I'm gonna make this bold. Okay. We can say with 95% confidence, because they asked us to find the 95% confidence interval, that now you look at the question. It says, it says find the 95% confidence interval of the mean reading scores of the fifth graders. Okay, that the mean reading scores, that on average, that you can say with 95% confidence that the mean reading scores, that means the average reading scores of all fifth graders, okay, is between 77.03 and 86.97. That's it. So first of all, you get the write down your values. You get the error margin as 4.97. You subtract it on the left side and add it on the right side. Then you get a confidence interval. Then you conclude. Any question? So we'll be timed that very soon. If we time that, wait for 10 minutes and log back in. Use the same link that you used to log back in. Okay? Hello? Can you hear me?
Okay, sir.
Okay.
Okay.
Yeah, if you time us, I'll just log back in after 10 minutes so that we can finish it. But we have finished this question. Now, this is the answer for this question and the conclusion. Yeah. So you can see that it's not that bad. It's really easy. And I'll see you in the next 10 minutes. Okay.